Physical quantity. A physical quantity is a physical property of a material or system that can be quantified by measurement. Fundamental or base quantities. A physical quantity which is independent of any other physical quantity is called fundamental quantity. Example, length, mass, time, etc. Derived quantities. Quantities that are derived from the fundamental quantities are called derived quantities. Example, velocity, acceleration, etc. The International System of Units SI includes 7 base units and 2 supplementary units, radian or RAD, unit for plane angle, and steradian or SR, unit for solid angle. Other unit systems include the CGS and the FPS and MKS. The base units for length, mass and time are CGS system, FPS system, MKS system. 360 degree equal 2 pi radian and 180 degree equal pi radian. Some special length units. Unified atomic mass unit. It is 1/12 of the mass of an atom of carbon-12 isotope, including the mass of electrons. 1 AMU equal 1 U equal 1.66 into 10 raised to minus 27 kg. Accuracy. It is the closeness of the measured values to the true mean value. Precision. It is the closeness of the measured values with each other. Least count. The smallest value that can be measured by an instrument is called least count. A. Absolute error. The magnitude of the difference between the individual measurements and the true value of the quantity is called the absolute error of the measurement. B. Mean absolute error. It is the arithmetic mean of all the absolute errors. C. Relative error. It is the ratio of mean absolute error to the mean value. D. Percentage error. It is a relative error expressed in percent. Dimensions. The dimension of a physical quantity are the powers or exponents to which the base quantities are raised to represent that quantity. Angle, strain, etc. has no dimensions. Dimensional formula. It is an expression showing the relation between fundamental and derived quantities. Dimensional equation. An equation obtained by equating a physical quantity with its dimensional formula is called the dimensional equation of the physical quantity. Dimensional constant. Constant having dimensional formula. Example, Planck's constant, universal gravitational constant, speed of light, etc. Dimensionless constants. Constants having no dimensions. Example, 1, 2, 3, pi, half, etc. Dimensional analysis and its applications. A. To check the correctness of the formula or an equation using the principle of homogeneity of dimensions, which state that the dimension of fundamental quantities on both sides of an equation should be the same, that is, LHS equal to RHS. B. To derive the relations among different physical quantities. Time period of a simple pendulum T equal KL raised to X, M raised to Y, G raised to Z, where K is a dimensionless constant. Taking dimensions on both sides, we get dimension of T equal dimension of M raised to Y, L raised to X plus Z, T raised to minus 2Z, or T equal K root of L by G. Limitations of dimensional methods. 1. These cannot be used for trigonometric exponential and logarithmic function. 2. These cannot be used to find proportionality constants. 3. Fails to derive an equation which is a sum or difference of two or more quantities. 4. Fails to derive an equation if any side of the equation contains more than 3 variables. Motion in a straight line. Difference between distance and displacement. Distance, displacement. Length of actual path traveled by an object in a given time. Shortest distance from initial to final position in a given time. Scalar quantity, vector quantity. Cannot be negative, can be 0 or positive. Can be positive, negative or 0. Similarities between distance and displacement. Distance displacement. Unit is meter. Dimension formula. Dimension L. For a body moving in a circular path of radius r, when it completes a semicircle AB, the distance covered equal pi r and displacement equal 2r. When it completes one revolution, the distance covers is 2 pi r and displacement is 0. Speed. Distance covered in unit time. Velocity, rate of displacement of a body. Uniform velocity. A body is said to be moving with uniform velocity if it covers equal displacement in equal interval of time. Average velocity, the ratio of total displacement to the total time interval. Instantaneous velocity, velocity of a body at any instant. Difference between speed and velocity. Speed, velocity. Ratio of distance to time. Ratio displacement to time. Scalar quantity, vector quantity. Cannot be negative, can be 0 or positive. Can be positive, negative or 0. Similarities between speed and velocity. Speed, velocity. Unit equal ms inverse. Unit is meter. Dimension formula Lt raised to minus 1. Velocity time graph for uniformly accelerated motion. Kinematic equations for uniformly accelerated motion. A. Velocity time relation. V equal V0 plus AT or V equal U plus AT. B. Position time relation. X minus X0 equal V0t plus half AT square or S equal to UT plus half AT square. C. Position velocity relation. V square minus V square 0 equal 2a into x minus x0 or V square minus U square equal 2as. Free fall. If an object released near the surface of the earth is accelerated downward under the influence of the force of gravity alone, the object is said to be in free fall. It is a case of motion with uniform acceleration. Variation of acceleration, velocity and distance with time. Relative velocity.